Please welcome Dr. Martin Williams. Martin is an associate professor in the Department of Physics at the University of Guelph. He also serves as the president of the Canadian Association of Physicists and is the former director of the Office of Teaching and Learning. Martin's teaching has been recognized through several awards, including the Canadian Association of Physicists Medal for Excellence in Teaching Undergraduate Physics and the University of Guelph's Distinguished Professor Award for Excellence in Teaching. His research focuses on pedagogy, the learning environment to improve student retention in physics, and enhancing representation in physics and STEM. So thank you for accepting this invitation, and I look forward to your talk.
Thank you, Matthew. Thank you for the invitation, and thank you for the extremely generous and kind introduction. I know that, well, I wasn't planning to live up to the introduction, but thank you anyway. And thank you all for coming out today to listen to a very, well, not a traditional physics talk. So I'm not quite sure why you're here, but welcome. All right. So I obviously am not going to repeat what I'm talking about. It's obvious there. But I want to start slightly differently by acknowledging the people who actually do the work, because there's this tendency that I have to get apparently run out of time when I give talks. And so acknowledgements are always rushed at the end of my talks, and it's not fair. Somebody said that probably it's because I talk too much. I strongly deny that. That's not the reason, but whatever. So acknowledgements. So there are two basic pillars in this aspect of work that we do. Sorry, Deputy. The two pillars are around gender and racialized minorities, or just minorities in general, in physics and broadly in STEM. And those are our two sort of interests at the moment. Well, it has been for the last sort of 5 years. The people who actually do most of this work, Eamon has finished up in December, and Sarah just started. Mary is my co-PI, and I like her because not because she's an engineer. I don't like her because she's an I like her because she has money, and I don't have any money. So that's really important. So all right. So does it make any sense to talk about this stuff, this gender gap stuff? What is the point of this whole business? I'm not gonna lay out a thesis to defend this stuff, but I just give you briefly. There's a lot of discussion around this, and I know you've heard arguments and that sort of stuff. But I just lay out my sort of motivation, my interest in this stuff, where it stems from. So there are two general arguments that I like. There's the so-called equity argument, and I'm not going to talk about the equity argument because I think that argument is well ventilated. And there's what I like to call the value proposition, which is, I think most people can sort of relate to. And that value proposition is that we think that our discipline is significantly poorer for the lack of those voices not being at the table. Yeah. So there is a business and innovation aspect to having these voices, that diversity of voices at the table. And this is not my idea. That's what the literature says. There's proof that supports that thesis, that differentiated voices lead to better outcomes, wherever it is, classrooms, businesses, et cetera, et cetera. All right, so that's my sort of motivation. Well, I don't think this is news to you, this statement. This statement should not be news to you. If you've sort of hung around classrooms or departments in physics, observations, the most cursory observation would tell you that women are underrepresented in those spaces. Yeah. What does that underrepresentation look like? And that is one of the things we want to talk about today, because there's more speculation than data in the space. Yeah. So you ask people, but actual hard data, it's not easy to come by in terms of what that underrepresentation looks like. All right, so what does it look like? I think most of you have seen this. Well, if you were interested in this stuff, this is Canadian data, which is always a paucity. You don't always see a lot of Canadian data. And there's nothing new here. If you're a student, a grad student, or a faculty member, these numbers should make sense to you. Yeah, they are what they are. So what about underrepresentation in not just physics, in other disciplines, And because I have an engineering connection, most of you, I would presume all of you would have seen this stuff. Yeah. So this is the mantra of the engineers: 30 by 30, 30% women, licensed women engineers by 2030. How are they doing? Sorry. Well, if you look at trends and trajectories, I don't know. So there are issues in other disciplines, and which is really interesting in terms of underrepresentation. All right, good. So those are the engineers. So, but it's not all bad news in STEM. There are other disciplines where representation is okay-ish, right? Actually, it's quite good. So if you look at some discipline called biology, or whatever, it seems to do exceptionally well in terms of representation. So, but probably when you, and I said, yeah, probably when you need to focus on for a second, it is probably these three disciplines here. So when we have to be careful when we talk about STEM, because representation in STEM is a very nebulous term, and we use it as sort of a throwaway. We need to be careful. So the first thing you'll notice there, that physics and engineering are in lockstep. We joined at the hips, unfortunately. So the blue curve there, the blue line and the yellow line, it's amazing how they follow each other. Yeah. And it probably shouldn't be a surprise to us. Why doesn't it shock us that the engineers can't live without us? I mean, we invented the thing. Anyway, yeah. Why do you think, this is for you, anybody, why do you think that these two curves are so aligned? Physics and engineering. Why? Well, you're not talking to me? You're like my students. You hate me like my students. Yes, absolutely. You should come to the front row. All right. So obviously, the physics pipeline feeds engineers. Yeah. As you know, in most schools in Ontario, most engineering schools, to get into engineering school, you require grade 12 physics. Yeah. So the engineers don't like us because of that, because they think that apparently, that we are to blame for their poor performance. All right. So, those are some sort of interesting points in terms of this sort of correlation between physics and engineering. All right. So why in heaven's name am I interested in high school? Why are we interested in high school? This is university stuff. I don't really care. I passed high school a little bit a while back. So our interest in high school physics stems from that. So we have this pipe. Engineers love pipes. I don't know what it is with them in these pipelines. They always, everything is a pipeline or whatever. So so you know that grade 10, most of you if you did high school here, that's not a necessary safe assumption. If you did high school in Canada, you recognize that in grade 10, everybody does science, yeah? There's no choice. So it's roughly 50-50. But after grade 10, the gates are open. So it's mandatory, all science. And after grade 10, they run for the hills, yeah? It becomes, you get to choose where you want to go. Yep. So, and then we see that for whatever reason, students don't like our discipline anymore. And so you see the biggest puddles occurring between what? 11 and 12. So if we want to affect this output here in university, we have to plug these holes here. Yes? Make sense? Yeah. So we're going back along the pipeline, plugging up here, because whatever comes out here at this point, this juncture here, there's little we can do in terms of changing that representation. Yeah. So the biggest change, if we want to effect that change, is probably at high school, hence our interest in high school physics. All right, good. So when we started this work, I was young and I was naive. I'm old and I'm still naive. So, um, um, so we thought, I said, this is really easy. This is a really easy problem. We get reliable data. Yeah, we figure out the trends, what the data is saying. We know the trends, yeah. Then we figure out why students make these choices. Why are they going a certain path, yeah? Get the data, figure out the trends, figure out why it is they're making the choices, then you disrupt those choices, you're done. Easy, easy, really easy. Oh, nothing, you can do that in a year. Yeah, good luck. So we're still at number one 5 years later. 5 years later, we're just starting number two, try to understand why students make, because to get the data out of ministries, good luck. Good luck. I've discovered things called freedom of information, FIPPAs and stuff that I never knew existed, because ministries do not release data. So yes, so we spent 5 years just to get data from all 10 of, well, 9 out of 10 of the provinces, yeah? And that was, yeah, something else. All right, so that's still the plan. That's still the plan. So figure out the trends, yeah? If we understand why the sample behaves a certain way, then we can figure out what we need to do to change the sample to get the output that we want. Yep, all right, so that's simply the plan. And so we started off there. This is all research speak. So we're going to start with Ontario, and then we're going to broaden out into Canada and look and see if these trends are repeated across provinces in Canada. And then we'll do some sort of intersectionality to figure out if these trends are linked to socioeconomic status, geographic areas, and all sort of, there's a number of reasons that explains this behavior. So the intersectionality bit is the sort of third aspect that we wanted to look at. Today, I'm just going to talk about these two because, oh, we're doing really good. It's only 20 to 12. I'm on a roll here. So, okay. All right. So, yeah, so we just have time to talk about these first, the Ontario data and the Canada-wide data. So that's what I'll focus on today. All right. So guess which province, we have data for 9 out of 10 provinces. If you had to guess, which province you think I don't have data for? Not Alberta, not Alberta, not Alberta. Who do you think we don't have data for? Not Quebec, not Alberta. I'm out of the camera? Oh, you can't see me. Oh, that's not a bad thing. So yeah, there's one province that we fought for 5 years and we're still fighting. I kid you not. Just this week, we're still fighting them. Manitoba. Manitoba will not. So yeah, but we're not giving up without a fight. All right, so the data generally, so what we have for all of the provinces, we have as little as 3 years of enrollment data and as much as 11 years. Well, for Ontario, we have right up until 2024, but I'm only going to speak to 2018 because something happened in 2019, 2020, I don't remember. Some major event occurred and we say it's just a perturbation in the data, but we figured that we need to leave that out for a bit while we study that data. So we're stopping, you see all of the data stop at 2020. We're not going further in 2020 because of that event. All right, so that is the plan. That's the general plan. This is the progression in terms of STEM, of the path that students generally follow in Ontario, in terms of high school, grade 10, compulsory, and all of the other stuff is optional. So these are the pathways they can take for STEM disciplines. And so basically, I'm going to show you what the enrollment in terms of the proportion of females across Ontario, all of the different STEM disciplines, and more specifically, we're interested in physics, yeah? We can look at those proportions, and then we talk about continuation rates. Where do they go after the compulsory grade 10? Where do they end up? We call it continuation rates because we don't like the word attrition. It's very negative. So we say, where do they continue? Not where they, yeah. Attrition is not a very nice word. If you're bored and you're interested in this stuff, you can read the publications and whatever this. A lot of the talk today is this stuff is published somewhere there. All right. So let's talk about Ontario. So what we have 11 years of data from 2007, 8 right up to 18, 844 schools. This is a typical data set, what we'll get from the ministry, what it looks like, and you know all of the letters down the side in Ontario. Who went to school in Ontario? Which one is physics? Which one is grade 12 physics? SPH for you. All right, good. So you see I'm not lying. So, all right, this is exactly in Ontario, the progression of courses that you have in Ontario. So let's look at data. Talk to you now. All right, so this is the total enrollment, STEM enrollment, all of the courses, all of the STEM courses in all high schools, those 844 high schools in Ontario's total enrollment, roughly about 125,000 students, less than that. And you see the distribution, because it's grade 10, the reds represent females, the green males. Notice how I describe this data is exactly the way the ministry collects this data and describes it. Yeah, it's not how I would necessarily, but this is how the data is currently collected and described by the Ministry of Education. Yeah, they only have 2 designations, male and female. Hopefully, I think that stuff is changing, but currently that's what they send us. Yeah, all right. So 50-50, roughly, you can see roughly 50-50. It was slightly interesting there. You can see that the enrollments, the total enrollment across Ontario is actually declining. Yeah, you can see the slope regression line. Yeah, yes, it is. No, it's not by a lot, but it's roughly about 1,000 students total enrollment per year. And most people, we believe that represents the decline in population provincially. Yeah, the Ontario, if you look up the Ontario, you know that the population, because people move out of Ontario because it's a horrible place. So I have to be careful. But roughly, I'm serious, there's a decline in the population of Ontario. People moved to other provinces and that sort of stuff, right? And that decline is what we think is captured there, right? Shows up there, yeah? All right, so what about What about the enrollments? So as they progress from grade 10, grade 11, so what's happening actually in the individual STEM courses? We started physics because we're biased. So to the right, we see the trends are already establishing. We see here that the significantly more males than females, yeah. And in physics, if you glance across at biology, you notice that that trend is roughly reverse as what we see if we're in classes in Ontario. If you went to school in Ontario, you wouldn't be shocked and surprised by that result. Chemistry, much better distribution, much more even distribution in chemistry. Mathematics, most of them have to take mathematics. We're not surprised there, but I think the two weird, quote unquote, weird ones, physics and biology, you can see in terms of representation, yeah, it's different. Grade 12, it doesn't get any better. We see obviously historically, grade 11, grade 12, the numbers, the enrollments fall. So there are fewer students generally enrolled in grade per discipline in grade 12. And we see again in physics that, yeah, the distribution of male to female, that ratio is not very good. All right. So those are I said there's nothing shocking here. All it confirms what you probably knew by observation, what you saw. Yeah. But this is data. This is what the actual data says. Yeah. All right. So I didn't talk. Yeah, we're not talking about that. Okay. You pass it. So another way we wanted to look at this data to sort of get some more sort of insight as to what is actually happening. We define this stuff, well, not define, it's the median, the proportion of female students enrolled in classrooms across Ontario, all right? And it gives us a little bit better insight of what's happening. So what we have here, so this is grade 12, grade 11. So what we're seeing here is that it's roughly the fraction of females in grade 11 math is roughly constant. Grade 12, obviously, the numbers is less than 50%. 50% of the population is females, and a slight increase, but nothing unusual there. So chemistry. What we notice here about chemistry is that consistently over the years, the number of girls taking chemistry is increasing, and the number of boys taking chemistry is decreasing. And yeah, so the gap is widening in terms of the ratio of males to females in chemistry. So this is gender gap. So on average, you can see here, it is more than 50% of the class. Yeah, all right, good. What do you say? What is there to say? So, and then there's biology, and then there is biology. And so you see the proportion of females, yeah, it's just amazingly, the slope of that line is significant. Yes?
Chemistry, biology, doctors, and most people do not do engineering or physics.
That's why they go into biology? Mm-hmm. Every time, and that's a really good question, but what I want to be able to answer that question with data, not what I think. Yes, and that is, no, I'm dead serious. Yeah. If you talk to every high school teacher, anyone around education, they have an explanation to what they see in the classroom. But we are scientists, we believe in evidence driven stuff. We want to see what the data actually, says. And that's, when we see these trends, the next step is to figure out why it is students are making those choices, right? Number two, and basically ask the students at different points in high school, university, wherever, when they enter university, when they exit university, basically ask them why it is that they made that choice. Yeah? And so surveys, interviews, just ask the question, right? But it's a good, I don't know the answer to the question as yet, but hopefully not in 5 years, less than 5 years. I can confirm or deny. All right. Okay. Any other question? Yeah. All right. Good. Okay. So, oh, we're missing one. One more I wanted. What are we missing here? Oh, physics. Yes. So what is happening in terms of the proportion of female students in grade 11 and grade 12? So this is grade 11. So you see the numbers here, roughly about 30%. And then that numbers fall, that number, well, yeah, between 30 to closer to 40. And that number falls to about 35. Yeah. The good news here is that line is not, the slope is not negative. The slope, this is the only good news you'll hear today. So I think it's, if we continue at this trend, behave yourself. Where are you going? Are you in a hurry? If we continue at this trend, hopefully we'll have gender parity 2103. Well, it should be okay. Yeah. All right. So, this is just basically the slopes of the lines, giving you some sort of indication. So you see that it would probably this line, the rate of increase here is 4 times. This is 4 times that. Yeah. So it's not good. It's not good. Yeah. All right. So the continuation rates or the attrition rates, as we said, we just basically following where students go after they leave grade 10, which is compulsory. They have choices. Where do they end up? Physics, those are attrition rates. Again, it's the same data. We just massaging the data and looking at it slightly differently. So we can see the gaps. You can see so this is the gender gap in 11. This is the gender gap in grade 12. Biology. What do you notice? There are 2 things that are very stark about that, about the biology result. One, that it's roughly the inverse of the physics. Yeah. And two, and I get into trouble. This gender gap here is actually larger than this one. But we don't talk about this one. We don't have to talk about this one. So there is a problem here. There is a problem. That's not, I'm not making this up. That's what the data says. Yeah. There are 2 gender gaps here. There's a gender gap in biology and there's a gender gap in physics, and it's worse in biology than it is in physics. All right, good. Chemistry, we can see that there is no, in terms of the proportions, I mean, people stop taking chemistry after grade 10, but there's no, in terms of preference, in terms of gender, it's roughly the same. And in mathematics, you'd expect not a significant difference between males and females in mathematics. All right, good. Those. All right, so yeah, we should be good. Let's talk about Canada. Let's see. So this is Ontario. That was Ontario. What about, I was told never to ever look at you. As a good teacher, never ever look at your watch during a lecture. Never do it. It distracts the audience. Well, all right. So I'm breaking all the rules. So let's talk about what happens Canada was happening Canada-wide. Yeah. Are the trends exactly the same, or is just Ontario is this outlier? He's got me. He's got me. So is it just Ontario is an outlier? What's happening in other provinces? All right. So, I know this plot is very, very busy, very, very busy. Also the colors, all of the rules broken again. But I just wanted, I persist to show the plot because I wanted to just talk about the trends, not the individual plot. So this is all of the 9 provinces, all provinces except obviously Manitoba. And it gives you a sort of indication of the proportion of girls or females in STEM over the last 12 years from 2008 to 2020, to 2020. And so this line here, this is the 50% line, and this solid black line is the average across all of the provinces. The average participation of girls in STEM across the province. And what you notice here is that this line is consistently above 50%. So the participation of girls in STEM is consistently above 50% and rising. So be careful when you talk about STEM. So women in STEM, good news, or if you use this broad term STEM, yeah? So we have to stop talking about STEM, AWT. Yeah, you have to be much more careful. And I said, so all of the provinces, it looks not too bad. Yeah. Grade 12, there's a slight drop as you would expect. Yeah, below the 50% line, there's a slight drop, but what was Ontario doing? Anyway, so but the general trend is the same. The representation in STEM for girls is above 50%. That's what the data says. All right, good. So let's talk about the individual disciplines. Let's see what's happening across the provinces. And we see. Biology, surprise, surprise. There's nothing here. So what happens in Ontario is exactly what happens across all of the other provinces in terms of participation of girls in biology. So biology 11, biology 12, you can see the line is actually trending upwards. Yeah, and this the average across the Canada. Yeah, exactly what you'd say, what you'd expect. Exactly what you'd expect. Oh, there are some interesting anomalies, if you say. Oh, interesting anomalies. So there are 2 provinces that appear to be doing spectacularly well, right? Aren't they? So we have Saskatchewan and we have Quebec, above 50%. Oh, so is this really true, or what's happening here? What's happening here? What is happening here? And you see, you know too many things. Yeah, absolutely. So why it is that these 2 seem to be way above the trend lines? What's happening there? Well, there's a really interesting, if choice is not always a good thing, like if you have too much choice, if you reduce choice, you can get answers that, yeah. So what happens in these 2 provinces? Well, we strongly believe, so we know that grade 10 science is mandatory. In Quebec, there's no grade 11 biology. So it means that you have instead of 1/3, you have a 50% choice, chance of doing physics, choosing physics, yeah? And also in Quebec, as if you're familiar with whereas in Saskatchewan, there's just a general science in grade 11, yeah? There's no individual sciences. So there's a combined grade 11 physical science course. So everybody takes the combined grade 11, yeah? Also, for the CEGEP, to get into, you know, the CEGEP, most of you, yeah, I'm sorry, not Canadian, that grade 11 physics and chemistry are both required for most STEM CEGEP programs, so they have to take it. They have no choice, yeah? And so that's what you're seeing, a reduction of choice, they take it, yeah. It is not, but in Ontario, where it is optional, they run for the hills. All right, so, and for Saskatchewan, grade 11 and 12 science courses requirements for graduation. So those so-called anomalies that we see, we think are explained by those phenomena. Reduced choices for students, increases the, changes that dynamic significantly. Yeah, all right, good. Yeah, I think this is a good place to summarize. So what did we talk about? We know that there's been a significant growth in female enrollment in STEM, that there's large disparities between courses, depending on if you're in biology or physics. Physics is still primarily male and biology female. The problem is there are large gaps, and some of those gaps are explained by changes in the difference in curricula. Physics will not win a popularity contest. There's slow growth, but that needs to be accelerated. Biology, not physics, has the largest gender gap. Yep. And well, we hope that biology will reach a saturation point soon, or that physicists will learn something from biologists in terms of how they manage to do what it is they're doing that we're not doing. I'm done. Okay, so first, the important conclusion, careful. When we're thinking about women in STEM, be really careful. We need to differentiate between disciplines. There are certain disciplines that have problems, but it's not true to say that women are not represented in quote unquote STEM. Yeah, and we need to figure out why it is students are making these choices. Yeah, to and then disrupt those choices, hopefully. I'm done.